It's a
This
very important
conference will now be recorded.
tool. Good morning, guys. Okay, now let's start with the Kubernetes today. What we'll do, let's discuss about the theoretically Kubernetes and Kubernetes architecture, Kubernetes components. Okay, all the topics today, and let's understand the what are the components are there. It's a very important question. If you go for an interview, they must ask this question. That much important today's session. Okay, minimum 2 questions, 3 questions, 4 questions, 5 questions on a same this today's session. They're gonna ask you. Okay, let's say. Okay, what is a Kubernetes? Kubernetes is a container orchestration tool. What is a Kubernetes? Kubernetes is a container container orchestration tool. Container orchestration tool. Container orchestration tool. What do you mean container orchestration tool? Sir, we have a Docker, right? A Docker compose we have, right? Why we need to Docker compose means that is a different scenario, right? We to want to run the multiple, and we have a Docker swarm also. Docker swarm also is there for container orchestration tool. Then why we need to Kubernetes on this? Now, Kubernetes has the more features compared to Docker swarm because the Docker swarm can allow for run the Docker containers only. Docker swarm can run for the Docker containers only. Okay, means it won't support any other container platform, but Kubernetes can support for different kind of platforms. And Docker swarm don't have a UI based dashboard. And even Kubernetes has the UI based dashboard. We can monitor, we can manage, we can delete, we can upload, we can create anything we can manage from the Kubernetes dashboard itself. Okay, we can create everything from the dashboard itself. That is another important difference. And there are few more important differences are there. We'll share that as a document that. Okay, that is a main features for the Docker Swarm and Kubernetes difference. And even though this is a lot of lagging for the features, okay, but Kubernetes has the many like as adding annotations, like as ingressing, okay, and in like as inbound outbound rules, okay, networking level, and private deploying the different namespaces. Okay, there is a lot more features are provided by the Kubernetes, but those features are not available in the Docker Swarm. Okay, like as maybe namespaces level or networking level, or um, a deployment method, easy method way, like as templatizing, like as Kubernetes has a helm templates, and those are the main features from the Kubernetes. And on top of more, it's from the Google product. Basically, it started in the Google. After that, it's moved on the CNCF. Okay, it's moved on the. It's basically it started from the Google, and after this, it moved on the. Right now, it's maintained by the CNCF. Cloud Native Compute Foundation, guys. Cloud Native Compute Foundation, guys. And this K8s, even though we call as a like Kubernetes, we are calling as a K8s. K8s. The tool name even we short form of the Kubernetes is the K8s. Means in between K and S, there is a 8 letters are there. If you want, you can count. Okay, that's the reason they are calling as a K8 also. K8 also. Okay, that is a main important. And let me see the some theoretical about Kubernetes. Some important point. See, the name Kubernetes comes from the Greek word meaning helpsman. Okay, this is the Kubernetes Greek word that is a helpsman. What this helpsman will do, he will run this like as ship actually. The person who steers the ship, the theme is reflected as a logo. The Kubernetes Greek word is what helpsman. Helpsman, what he will do, he will steer the ship. That's the reason they keep it the logo like this Kubernetes. Understand why this logo came, just for information about that. That is not that much important for us. Anyway, you will often to see the named short name called as K8s. The idea between the number 8 in here, the Kubernetes is leading the container orchestrator that let us manage the containers apps in the scale. We give it app and tell the what we want to see. We give an app, tell what we want app look like, and Kubernetes will make all the hard decisions about the way to run, how to keep it running, everything. Who will take care of? This Kubernetes will take care of. Okay, all those things who will take care of? We just hand over to the what we want, and the Kubernetes can manage for the what, like as anything where it wants to run, like as how it wants to run, how want to keep it up and running. Everything take care by the Kubernetes. That's what we discussed yesterday also, right? Okay. Now let's discuss about the Kubernetes architecture. Let's discuss about the Kubernetes architecture. Understand, right? What is the theme for Kubernetes, guys? What is the theme for Kubernetes? Means Kubernetes for container orchestration tool, and you should submit that what application you want to run, how many applications you want to be run, and you can hand over to the Kubernetes. Kubernetes is managed by, like as where he wants to run, like as how, like as it's running or not. Everything will be decision taken by the Kubernetes. You don't need to worry about that. Even if you submit once, you can go around, say, sleep and then enjoy your sleep. Okay, that's what we can do with the Kubernetes. Okay, Kubernetes will take care of maximum stuff. I mean, it's a deployment purpose, and even the Kubernetes itself go down, then it can't do anything. Understand, right? What I mean? Like as Kubernetes, where you install the Kubernetes, the node itself will go down. What Kubernetes will do? Kubernetes also will sleep around. Say, okay, understand, right? What I mean? If the Kubernetes software is up and running, that's fine. If the Kubernetes will not running, then gone. Okay, understand, right? Okay. The next, this is the basically how what is the Kubernetes? Kubernetes has the master slave kind of concept. Okay, it's a cluster. Kubernetes is concept is called as a cluster. I mean, there is a one master node, and and then we have a number of slaves actually. Number of slaves we had. These slaves, and now slaves means this also is Linux machine, and Kubernetes master also is a Linux machine. But where we install the Kubernetes, that we are calling as a master, where we are not installing Kubernetes. Like like Kubernetes means what? These are all the components. These are all the components called as a Kubernetes. These are all the components is called as a Kubernetes. That is, we are calling as a master node. We are calling as a master node, like same Ansible host machine we are calling it, where we install the Ansible. That's the reason where we install the Kubernetes, that we are calling a master nodes, where we are running a agents here. Like as cube, that is a agents means this is a nodes. Agents are nodes, or may old people that are calling the minions. Okay. Now there is a different names for this. Okay. Now this also running a kubelet here. Kubelet for every node, and then here Kubernetes is running. In this master node, all these components are there. What I mean, let's go to this. Inside this, it will run. Right? Okay, all these components are in the master. What are the components are there? This is the one. Remember, it's a very, very important. They will ask interview question. What is the master node components in Kubernetes? What are the master node components in Kubernetes? Means these components we need to be set up in master node. What are those? Cluster store, controller manager, API server, scheduler. Okay, tell this way. API server, cluster store, controller manager, and then scheduler. What are those again? API server, controller manager, cluster store, scheduler. Okay, let's come this way. Okay, let's do it. It can easy to understand. And API server, controller manager, cluster store, and scheduler. These are the four components are very, very important for in our Kubernetes master node. And these four components, what are the each component can do means now basically we are gonna return for one YAML file. Guys, listen carefully. Okay, remember these names. Very, very, very important question. And here we are gonna return some YAML file here, like as I mean now API server, API version. Okay, and kind. Okay, and metadata and spec. Some syntax like this for every Kubernetes cluster have the some syntax like this, and this is the we've written this syntax as a YAML file format or YAML or YML, any format we've written. Okay, and this YAML files we are going to return. Once this YAML file is written, what we do, we go and we submit to the API server. Alright, take this one. This is as the REST API endpoints in the API server. When we do the Kubernetes apply command, it will go and it will hand out to the API server. API server, after taking the API server, it will be take and then it will be tell to the controller manager, array manager, I got this data. And controller manager, what will do? It will keep it the data inside this now the cluster store, like as what, like as how many containers you asked. Okay, where these containers are asking. Okay, running and everything, the information stored in the, like as how many you asked, all the node, all the your application information, how many replica set means don't confuse too much, how many containers you want, that number will be stored everything in the this cluster store. Cluster store is a one kind of database. It's a key value pair database, and this database we are using a etcd. Etcd is the one database. Etcd, that is a key value database store. We are using that, this here key value pair data store that we are using is a cluster store. And after this, it will be gone, it will hand out to the scheduler. And scheduler what it will do, it will go and it will run on the nodes section. This scheduler will schedule in containers in the nodes. That means this scheduler will go and this scheduler will be run a container, like if you ask two containers, now this will be run on the one container this node, one container will be running on this node, any whatever, maybe it depends on the scheduler will be take care of where they want to be run, where they want to be run. Now it will go and hand over to the Kubernetes API server, and then it will go and hand over this next controller manager. It's managing for the all the next time, and then it will store into the, like as this cluster store. Cluster store means what are the application name, what are the containers you asked, how many containers you asked, and those information will be managed by the API server. And the next, the scheduler will be take care of next. The scheduler will go and will hand over to the nodes. The node will be running for my containers here. This here is the one container, this here is the one container. Another application, let's say you ask the three containers here. Okay, like that it will be run for application the node level. From here we are using some load balancers, and we are accessing this application for as a load balancer. And we are acting as a person. The person will be in front of the system. He can access this load balancer URL. From load balancer URL we get this application is running here. We can get to know if anyone will go down, this controller manager will be looking for every time, like as any these two containers are running, like this application has two containers, two is running or not. No, it is two is, like as say this two is not running, then what it will do, if it is anything is fine, no, okay, it's a three, right? Any, like only two is running, three is not running, what it do, it will go and it will create a one more container here, this node or this node, whatever, what are the node, it will be free or it will be available, then it will go, it will be spin up the another container. Means at any time you can do. So Chandra, how many nodes you want, you can add, that's not a problem. Okay, that depends on your load, depends on your load and depends on your applications. Clear? That depends on how many containers you want, that many nodes we can add. Okay, like how many applications you have, how many containers you are managing. Okay, and depends on your requirement, and depends on that how we can decide that. That decide will happening for the your and your manager and your teammate and all things. First day, what we'll do, we'll deploy the 5 nodes. No, it is not sufficient. The containers are not enough because your application giving me like as what you can say, slowly responds, not responding properly. Then what you thought to container increase the containers 10. Now that time okay fine, but the nodes are going down. The nodes are not responding properly. Then adding for one node. No, this is the load testing happening. Then you will understand that okay, for this scenario, for this many customers, for this night time we need this much, like as office working hours, like as customers using hours are non-working hours, this many nodes are we are using. Okay, like increment decrement, all those we can happen by the automation, writing some scripts, or like managing the nodes, auto scaling. Okay, something we need to set up here, and based on that auto scaling we are gonna increase or decrease happen in the based on your workload in your nodes, right? Clear? Clear, yes? Understand, huh? Now let's see, discuss about the each and individual again as a theoretically as per this diagram. Let's go on see this. Now go for the API server. What this API, this master node contains? A Kubernetes cluster made up with the master and nodes. These are the Linux host running on the anything from VMs or bare metal servers or any cloud also. Okay. Now master node. The master node we are calling as a control plane. Master node itself, there is a name called as control plane. We can call master node, we are calling as a control plane. That master node we are calling as a one more name called as a control plane. A Kubernetes master is a collection of small services and make up the control plane of the cluster. What is the first one is the API server. What is that API server will do? The API server is the front end into the Kubernetes control plane. Control plane means master node. It exposes a RESTful API to preferentially consumes the JSON or YAML files, whatever could be. We post the manifest file. Manifest file means this is the YAML file. Whatever we written, right? This we are calling as a manifest file. All these YAML files we are calling as a YAML files. Okay, these files, okay, the manifest file to get validated and work, they are different device that gets deployed into the cluster. What will do, it will validate the your YAML file. If it's everything is fine, there is no syntax issue anything, then it will go on for deployment. How it will go for deployment next? Now the next we are thinking about the, you can think about API server is the brain for your of the cluster. What is this? API server is as the brain of your cluster. It's a brain, like as what exactly to do, what next to do, who will tell us? Basically brain will do that, right? In for a human being, understand, no? The same way API server is a like as a brain kind of for Kubernetes. Okay, this cluster store is cluster store, it kind of a memory. Your memory, it's a brain and memory. Sir, brain and memory both are same? No, that is a different. Okay, understand, no? Now the cluster store, the API server as the brain of the cluster. Let's say this is the API server, it's a brain kind of the cluster, and cluster store is a memory. Okay, it's cluster store is a memory. The config and state of the cluster and gets persistently stored in this cluster store. The whatever the state of the cluster and gets persistently stored in the cluster store. The cluster store is based on the etcd, the popular distributed consistent watchable key value pair key value store. And as it's a single source of truth for the cluster, you should take care of the to protect and provide the adequate ways to recover things go wrong. And this is a very sensitive one. If you lost this etcd data, then gone, entire your application will be go down, like as you can't able to manage. That's the reason we need to make it a protect, and we need to take a backup properly. This all this you should do, take care of ourselves. If anything goes wrong, then gone, then gone. Okay, clear? Understand, guys? Okay, the next, that is the etcd. That is the another, this is a controller manager. This controller manager, what will do, this is the leader, like I say, hey, I am doing for all the stuff. What it will do, the controller manager say these three guys are employees, and controller manager is a manager for the three employees. Okay, let's think about that way. This controller manager that we are calling a cube controller manager also, the name, it is currently a bit of monolithic, implements a few features of function that is probably get split out the made pluggable of the feature. Things like as a node controller, endpoint controller, namespace controller, like this. Okay, all this can be managed by the this controller manager, and they tend to sit in the loop. See what it will do. These are the controller managers. Okay, node controllers, endpoint controllers, no namespace controller, everything managed by the this controller manager. They tend to sit in the loop and watching the changes. It's a sit in the loop and watching the changes. The aim of the game to make sure it will make it the current state and the desired state to make it for up and running. This controller manager, what it will do? It will do like different controller controlling things like as node controller, namespace controller, and then endpoint controller, all the things. And the main about this controller manager will do, it will be maintained by current state and then desired state. Okay, that means we spoke yesterday, if you remember. I mean, for example, you asked, I want on the 10 containers. This is for what? This is your desire. This is your desire. And in the cluster, there is a 9 containers is running. This is the current running. No, it is not matching. Whatever you asked, this is you asked, but it's running. This is running. What happened? We are gonna create for this Kubernetes is gonna create for one more container for you. Then what happened? This totally will come 10, 10, 10 equal. Then the Kubernetes controller will be happy. That means he will only do that for us. Okay, that is what is the control, like as desired state and current state. Now this is all about Kubernetes maintained by the desired state and current states, and imperative model and declarative model. This is the concept in Kubernetes. That's it. Imperative model, declarative model, current state, desired state. What is imperative model, declarative model? We'll see the next. And then understand that desired state and current states means how many you asked, how many running, how many you asked, how many running, how many you asked, whatever you asked, whatever they are running. Like this. Desired state and current state. Okay. Understand? The next. This is a controller manager done, then scheduler. Okay, this is the guy who would do work. Actually, this is a fresher guy. Let's say this fresher guy do for all the things. He will get a requirement. Okay, then he submit to the cluster store, and he is he will tell to the controller manager, this controller manager, this is the new thing came. Okay, fine, I'll take care of. Then next scheduler is the like it's a fresher guy. He is doing for all deployments. Okay, let's see. This a high level, the scheduler is the kube scheduler, watches the new workload. It is looking for any work is coming for me anywhere, and assigning them to the nodes. Behind the scene, it does a lot of related tasks such as evaluating affinity, anti-affinity, constraints, resource management. Everything will take care by the like as how many nodes are running, which node is free, which node is available, all those constraint affinity, anti-affinity, all like as which node you want to deploy, which node you don't want to deploy. Everything will be taken by the this scheduler. Affinity and anti-affinity means that you will know that feature going on in us those node selector, and then those we are going to mention in the pod manifest. Again, what is a pod manifest? We'll discuss that in the future. We will get to know that. Here, guys, clear now? What is the scheduler? This is all about the components. Understand, right? What is the API server will do? This API server will be, we are going to submit the manifest file, and it will work as a brain. And the cluster store is kind of a memory. Whatever we are submitted, that will be stored in a key value page store, that is etcd. And controller manager will be managed for the current state and desired state. And the scheduler is managing for the to deploy your application in the nodes. Is it clear now? Orally? All. See, the Kubernetes masters run on the cluster control plane, all the services. This is the brain for the cluster where all the controller scheduling decision are made. Behind the scene, master is made up the lot of small specialized services. These include the API server, cluster store, controller manager, and scheduler. API server is the front end into the master to the only component to control plane that will be interact with the directly. By default, it expose the RESTful API with the port 443 means it's a HTTPS port. It's a HTTPS port. This diagram is taken from this Kubernetes book. Even I'm going to share with this book, guys. Okay, it's available from Amazon. Even if you want, you can buy from this book. Okay, the latest book. Okay, next is the nodes. Okay, next is the node. Okay, now what do you mean node? All this, whatever I'm talking, this component, right? This component we are calling a node. This component is the node. This is the node. This is the node. This is the node. Okay. Okay. This will be running for every node. Okay. Let's say think about this. This is, leave it about this. Okay. Now this means every every node running for these components means now which kind of container you want to deploy, like it's a Docker or we saw that container D. Okay, another one is the ISO or what, another container format, ISO or something I showed right yesterday. What is those guys? There is another container, like let's say anything like as RKT. Okay, like as container D, or as let's say Docker, anything, any container platform you want to run, that we need to install in the every node. Without running that, you can't to be run your containers. Okay, like as which is the platform to run your application, that we need to it's a, like a software, engine, Docker engine, that which engine you want to run your containers, that engine you need to be installed. That is the one thing. And all about the node is called as a, it's a, what it contains, kubelet. The kubelet, what is this kubelet will do? This is the kubelet for is the every node is running. This kubelet is running for every node. What it will do, it will checking for like as containers is running or not. If anything goes down, what will do, this kubelet is go running very very fast, will go running. Array, controller manager, there is a one container go down in my node, can you please check? Understand it? Just funny I'm telling. Okay. Okay, understand right what I mean? This kubelet, what will do? It won't do anything. If anything go down, what it will do? It will go running and it will tell to the controller manager. Array manager, one container go down, man. Okay, okay, cool. I'll take care of. The controller manager will check for what is the application, how many it running. It will go and check in the cluster source. Then after that, it will tell to the array scheduler, go. This run for the this running only one, and go and run the another container. Okay, that will scheduler will go. Scheduler will be running on the that container in the node actually. Understand right? Means the kubelet is managing for the to run. It can't be run the containers. Okay, you don't have an option to run the container. It's like a small guy. Okay, I mean, understand right? This is a kind of agent. It will, if something goes wrong, any container running container will go down. It will go and it will tell to the control plane only. Then control plane means controller manager, that will be take care by the next, what next will do. Okay, that is the kubelet. That is a kubelet. And then container engine. That container engine means what are the containers you want to run, that need to be installed. The network proxy. The network proxy is running for this a daemon set, which is running for every node, because it is assigning a IP address for your containers. Who will assigning IP address? This network proxy can assigning IP address. Very important question. They're going to ask that. What is the network proxy? The network proxy is a daemon set which is running for every node, and it is assigning to the like as IP address to your pods, and even it can be managing some kind of load balancing in the in between the multiple pods in the same node. Multiple pods in the same node. Mainly, it is the intention of the is a QB proxy. Network proxy means, okay, maybe some people are calling QB proxy, or some people are calling as a network proxy. Let's think about the both are same. Okay, someone will ask what is a QB proxy, what is the API, like network proxy means working is same. Okay, understand right what I mean? The network proxy, it will assigning a IP address for every. In this terminology, we are not calling it container basically. Okay, in this in the Kubernetes terminology, we are not calling as a container. In this terminology, the application is running as a pod. What is the terminology we are using? Pod. What is that? Pod is equal to our container. Understand, right? Okay, pod means container. Think about that. But in a pod, not only one container, we can run the multiple containers also. Okay, in a pod, we can run the multiple in the single pod, multiple containers we can run. Inside the pod, there is a container only running. Understand, right? What I mean? This is the pod. Inside the pod, container will be run. Even one container, two container, three container, five containers also we can run in the single pod. But in real time scenario, we won't run the multiple pods in the single pod. Only one main application, maybe supporting containers may be run in the pod. Okay, we'll see this in the next. Understand, right? That means it's running on the applications running means in this terminology in Kubernetes, you guys can think about it is a pod. You guys think about it's a pod. Application running where? Inside pod, inside pod, inside pod. What is inside pod? It running. Container only will running. Container only will running. Okay, we'll see like as how to run a pod, how to check a pod, what how to check the what is the containers are running. Everything will get to know that. But you can't use the docker ps command, docker run command here. Understand now? What do you mean? Clear? No, that is everything is a parts. Everything is a part. We'll see that. We'll see that. Understand these three components: kubelet, container engine, and network proxy. What exactly will do? Okay, it's clear now, guys. Let's see that again one more diagrammatically here. The kubelet. What the kubelet will do? The first and foremost, the kubelet. The kubelet means is a node basically to run on all the cluster nodes. In fact, the way to say kubelet is the node. Kubelet is the node. Okay, you install the kubelet on Linux host and the register as a host in the cluster as a node. It watches the API server of new work assignment. Anytime it sees one, it carries out to the task and maintain the reporting channel back to the master. This is what. Okay, it will reporting back to the master. And if the kubelet can't run the particular work task, okay, it reports to back to the master and let us control plane will decide the what action to take. What it will, that's what I told now. What it will do if something goes wrong, anything done, it can't be run. It will go on running very very fast, and then it will tell the control plane. Control plane. Array mama, it is running one container is down mama plane. Please do mama. Now this kind of okay, you don't worry mama. I'll do like I'll take care of myself, and it will run. This is the guy can be tell to the master. Sir, how it's happening internally? That is the components communication. That is the relationship between the software. Understand, right? You guys can think that way. Okay, that's very easy to understand what exactly each component can do that. Okay, that you can think about. Okay, let's see this now. I mean, kubelet won't tell to mama. Okay, that is just I'm giving simple explanation. Okay, don't think about kubelet will tell to mama. No, no. Okay, that is just simple way I'm teaching. Okay, just it is. This is the word. Technically, this is the word. The kubelet can't run the particular work task. It reports back to the master. That's it. It's just report back to the master. That's it. Okay, this is not telling the mama model. Okay, don't think. Okay, it reports back to the master and lets the control plane decide what action can be taken. Now, for example, if the pod fail in a node, kubelet is not a responsible to restarting, finding the other node to run it. Okay, that is what intention. Okay, what it means is any pod will fail in the node. The kubelet is not a responsible person for restarting and finding another node to run on it. Okay, who will take care of it? Simply reports back to the master. The master decides to what to do. Okay, on the topic of reporting back, kubelet is exposed these port numbers. Okay, remember this is the ports are very important. 10255, and that is the port where we can inspect it. It's a what to knowing the port, and the know on your nodes to let inspect as the kubelet using this port, and it will be this is the channel to communicate. Now if you want to access the Jenkins, how we are accessing edge ledger, right? This kubelet will communicate with the master using this port. Okay, remember that. Okay, what are the components? This is the one. That is the kubelet is the one, and container runtime. The container runtime means the kubelet needs to work on with the container runtime to do all the containers management stuff like pulling the images, starting the stopping the containers, all those. Which kind of platform you are running? That container platform you need to be installed on that. You need to be installed on that. Okay. And the next one is the Kube proxy. Okay, Kube proxy is the last piece of in this Kubernetes architecture, and this is the like a network brain of the node. For one thing is it makes sure every pod gets its own unique IP address, and it also does lightweight load balancing on the node. Okay, it's assigning IP address, and it will do some lightweight of load balancing also internally that pods. If the two pods are running, which pod you want to get a response, that will be decided by the this kube proxy. Okay, understand, guys? All components, everyone. It's a very, 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 very important question. They're gonna ask like what scheduler will do, what the API server will do, what is the network proxy will do, what is the cluster store, what are the components in the master, what are the components in the node, what is the difference between the kubelet and kubectl. This is a very, very important question. People will confused. Kubelet and kubectl. Okay, this kubelet, what will do? It's a component. It's component in the node. This kubectl is the CLI tool to manage your Kubernetes cluster. Means Docker commands we are doing, right? In the Docker commands, what we'll do? This is the using this tool we are going to kubectl CLI tool. In a Docker commands, Docker container, Docker PS, we do right. That's CLI. This kubectl is the CLI tool which we can manage your Kubernetes cluster, means deploying and deploying, like as checking what are the content, what are the pods are running, what are the services running, what is the deployment object running, what is the like replica set running, what is the like as daemon set pod, replica set, percent volume claim, all those each and every things you want managing with the kubectl. Kubectl. Is it clear, guys? Okay. That is a two important question they're going to ask. This is the very, very important session for interview point of time. When they start Kubernetes interview question, they will start from here and they will go many components or many topics we will discuss one by one in our course. Okay. It's a very, very, very important. Okay. Fine. Then move on. Move on to the next. As it's a feel like little bit difficult. It's not be like a single command to install a software. It's not be a single command to run a software. It's not be like that. There is a lot of people. As I've written for installation document for 20 pages. Okay. Even sir, even there is an option. When a single file we can set up that. That also I'll teach you what I mean, right? There is a 3 lines of code also we can create a cluster. Even single command also we can create a Kubernetes cluster. I'll teach you that also. Okay, but that is not a way to learn the components and the communication, what happening internally. Okay, that also will teach at the end. Okay, but as of now, you need to understand the pain of the Kubernetes. Then, like you can pain for the Kubernetes installation, components, communication, and that how the Kubernetes nodes will be work, and the master will communicate with the nodes, and then how to check the nodes, how to check the components, everything. Once you get to know that, then what we do, let's go and set up for very easiest way later. So fine, now see that one topic exactly what I'm going to talking till now. Let's take an example. See, listen carefully. This is the all about declarative model and desired state. Declarative model means YAML files. Desired state means what you asked. Okay, declarative model means the YAML files we are writing inside. What desired state means how many you asked, what you asked. Okay, now declarative model and concepts of desired state are two things are very hard of way to Kubernetes works. Okay, that's what I don't know. Desired state and current state, declarative and imperative. Okay, imperative means just running a command, simple, like as Ansible had a commands we are running, right? The same way in Kubernetes also we can run that commands, but in Ansible we are calling is the Ansible ada commands, and in Kubernetes we are calling is a imperative way. That is we are calling is running that commands like a imperative way. Okay, that means you don't know, you are not storing any the data information like what command you run and all those things. You just run and you left about that. But if any other person want to know that what you run, they don't know. Okay, that's the reason we are not doing for any YAML files, any deployments using the simple commands. We are writing for declarative method. Okay, declarative method means writing a YAML files, and that YAML files will keep it the GitHub or somewhere source code repository, and it can be used for the next future guys. Next future guys. Okay, let's move on. Let's see. This is the concept for understand the Kubernetes. What it will do. Okay. And the Kubernetes the two concepts work like this. These two, like declarative and the desired. We declare a desired state of our application, like a microservice application, to manifest file. We post to this API server. Means that I discussed right just now. We mention everything in the one, declarative method, means YAML files, and we post to the API server. We post to the API server. Just think about this, guys. Whatever I'm talking, we mention this and we post to the API server. We post to the API server. We post to the API server. After that, what happened? The Kubernetes store. This is the cluster store the application and desired state. And what happened? Whatever you post, it will store in the Kubernetes cluster store, like as how many URs and that all those information. And the next, Kubernetes deploys the application to the cluster. Who will deploy this? Basically, this scheduler will go and deploy to the cluster. And these are the managing by the this controller manager. And the Kubernetes implement the watch loop. Okay, and make sure does not vary from the desired state. This will be checking for the watch loop. It does not vary from the desired state. Desired state where you mention in the API server. Like in this YAML file, you mention the desired state that will be stored in the cluster store. Like a desired state means what? I want to 3 containers you want to be run. If any, like as if your 2 containers running desired state, you ask 3, current state is 2, then it will create a 1 more plus 1 for us. Okay. If 3 is not running, 3 will be created. 5, like 3 is running, it won't create anything. 1 is running, 2 will create, like that. How many less, that many create will. It won't be like that, there is a 1 container running, again they won't create a 3 more. Okay. It not be like that. It will check how many less are there. Okay. Understand, right? We'll see in the hands-on also practically in the going on further classes. You will guys will be feel like yes, okay, this is the what. Just understand theoretical concept now. Let's look at each and every step in detail. Now manifest file, either we can write in a YAML file or JSON file. Okay, this file we can written in the two formats, YAML or JSON, anything we can written. But in real time scenario, maximum 90% we never written for JSON, we written for YAML files mostly. Okay, and they tell to Kubernetes how we want our application to look. We call to the desired state. That is what, I guess, how many you want, that we are calling as a desired state. It includes things like as which image to use, how many replicas we want. Replicas means how many you want to run, like a 2 or 3 or 4 or 5, like that count. Okay, and which network to operate on, like as how to perform updates, everything. We are gonna all this information keep it into this YAML file, and the YAML file we are submitting to the whom API server. Once we created the manifest file, that YAML file we are calling as a technical terminology in Kubernetes, that we are calling as a manifest. Once we create that manifest, we post to the API server. Okay, we post to the API server. The most common way doing this is using kubectl command. That's what we are doing that. This sends to the manifest to port number 443 to the master. Kubernetes inspect the manifest. This Kubernetes components inspect the manifest. It identifies the which controller to send it, an example deployment controller, and it regards to the config and cluster store. That is the data, whatever it will be under the configuration you are made, that will store in the cluster store as part of the cluster overall design state. Once this done, it work gets issued to the nodes to the cluster. This is include to hard work to pulling the images, starting a containers, building a network. All those will be taken care by the who. This is the all scheduler, all these things. Finally, Kubernetes is set up background like as reconciliation loops that constantly monitoring of the state of the cluster. If the current state of the cluster varies from the desired state of Kubernetes, it will try to rectify it. Okay, not only the declarative model, lot of simplified long list imperative commands also. It also enable for self-healing, scaling. Okay, that we'll see this. What is the imperative model? How we can set up this later sessions. But the declarative story does not end here. Things go wrong. Okay, things changes when they do. And the current state, then the cluster no longer matches the desired state. As soon as it's happened, Kubernetes kick to action, does everything it can be, bring the two back to into harmony. Let's look at the example. Okay, see, for example, let's think about this one example. Assume you have an application. Assume you have an application and you ask the 10 replicas, means the same application you run the 10 times, 10 containers you want to run. Because why we need to 10 containers? One container is not enough for to respond for all my clients. Okay, like as people are using, many people are using this application. If you run the one container, then if that container go down, then gone. That's the reason we run the same application the 10 containers. Have you guys have seen that, right? In when we discuss in that Docker, we set up a load balancer. We run the two containers, same application, the two different nodes. Why we run that? If one thing go down, another one will be respond for us, right? But that down one, no one will be managing. But here, the Kubernetes will manage immediately if something goes wrong. Understand that means high availability purpose. Why we are running the multiple containers? To make them high available, to make them high available. Okay, and see the 10 replicas we want to run the application, that is a web front like front end pod. We know that we running the two replicas, like let's say in case two is died and the current state is the eight replicas, you because you asked 10, two is die and then 8 is running, but desired state is will still 10. Desired state means how many you asked? 10. This will be picked up the reconciliation loop and Kubernetes will be scheduled the two new replicas in the node in the cluster. And it will be combining like at that time 10 you ask 10 is running. The same thing will happen if we intentionally scale the desired number, like intentionally we decide the scale the number desired, and means like 10 you this time today is 10, like tomorrow like a 15, let's say 15. The replicas up and down, like as if you want to increase you can increase, if you want to decrease. Based on that it will be managing. We could even changes the image we want to web produce. For example, the app is currently running this version and this version to this version. Kubernetes will go through the process updating all replicas they are using the new image. Okay, how this is done by that we can see this scaling, changing the image, everything we'll discuss in the hands-on. Okay, through this might be simple, okay, but extremely powerful, and it's a very easy, very hard to how Kubernetes operates. We give the Kubernetes declarative manifest that describe we want to application look, the the forms of the basis of the application design state, the Kubernetes control plane records, it implements it, and it's run in the background, reconciliation loops, and constantly checking what's running, what is not running. And when current state is does not matches the design state, the it will be creating for that. If everything is working fine, then we are happy and the customer happy and then manager happy and then everyone is happy. Okay, that's all about the Kubernetes. What exactly? Simple. Kubernetes is a kind of watchman for us. We'll tell to this guy that will be running for any time. Like as you want to run the 10 containers, the Kubernetes will take care of it. It's try to make it for all whatever you asked at any cost. Right? It's a 10 containers you asked, 10 it will be running or not, it will checking every time. If you are not running, it will go on creative that whatever less containers are running. It will checking for every time desired state and current state should be matchful. Okay. Fine. Now let's move on the terminology, Kubernetes terminology. Now here we already know master and the slave. Master and slave. And the next we are calling mainly everything as a pod here. The main thing is the pod. This is the pod is the main component in Kubernetes. I mean, where you run application, it's a run your application. And remaining components are, that is the purpose why we are using. The mainly running application is running for where? Inside your pod only. Inside your pod only. Okay. But what is the pod? A pod is the, like I see, in a VMware world, the atomic unit of deployment is called as a virtual machine. In a Linux machine level, if you want to deploy any application, what we are using? We are using VMs. Okay. In the Docker level, what we are using? Container. In Docker level, we are calling container. In Kubernetes world, we are calling as a pod. Understand? No? Clear? The difference between the VMs, containers, and Kubernetes. That means in a Kubernetes, we are calling a pod. In Docker, we are calling as a container. In Linux mission, we are calling as a VM. Means a pod is called as a, again, one more Linux mission. Let's say, think of small Linux mission. Inside the Linux mission, containers will be run. But container is as a called as a one small mission. Inside that container, our application code, everything will be there. Pod also same thing, and VM also is same thing. But VMs are little bit size, and containers are not manageable, and pods are managed by Kubernetes. Understand? See the difference. Clear now? This is all about the pods we are calling. The pods and containers. What is the pod? Basically, we just discussed about what inside the pod. A pod is called as a atomic unit of work, and which we are running for application inside the pod. Closing this. Okay, this is the let's say let's run this way. This way. Let's say it's a pod. Let's say it's a pod. Inside the pod, what happened? Your container will run inside that. You run the one container inside your pod. You run the container inside the pod. Sir, can I run the multiple containers in the pod? Yes, obviously you can run. What happen if you run? If this pod go down, mama, like as 5 containers you're running that even one container only, let's say one application you're running for everything in the single pod. What happened? This will go down. What happened? Entire all application go down. Yes or no? Right? Now that's the reason we won't do this mechanism. We run the one application. Like if you want the 5 application in that, what do you do? 5 parts we create. Not the same application. Let's say this is the application one pod, and this is the another application. I mean, this is the DB application, this is the front end application, this is the back end application. Okay, this is the anything. It's a back end, it's a front end. Let's say it's kind of any like different application. Okay, this is the another one is the another backend application. Any application. Let's say another one is the let's say UI application. Let's think about that. Anything. Now you won't run the every part we run our containers. Every different parts we run our applications, because this is the good way we are doing that in real time scenario. For every pod running for one container, it's not running the multiple containers. Sir, are you sure? Yes, this is the main reason we are using, because if pod will go down, that entire pods will be gone, right? And that could be the reason we are running on each pod is a one container. Sir, basically it's not only one pod. They may have, remember, they may have the supporting containers also. That supporting containers also, if has, that's fine. If you don't have, that's fine. Some pods may have the supporting containers, some pod may not have the containers like supporting containers. Those containers we are calling as a init containers, sidecar containers we are calling basically. Okay, that terminology we will discuss later. But there is a supporting containers. For example, let's say before running the script, you want to run the another application that installs the some credentials creation, or installing some software, or checking the softwares are there or not. Okay, let's say like is whatever it may be, what is the operation you want to do, those you want to do that using that container, that is a supporting container, like any agent or anything, whatever. Those we are calling as a supporting containers. It may has, may not has. Okay, that depends on your application need to be. Understand? Clear, guys? Clear now? What is the pod? Pod is the atomic unit of work which we are running inside the our application, our pod. Okay. Now, if you see here, pod at the main container and the supporting containers. Okay, that depends on pod autonomy is the at high level. The pod is a ring-faced environment that run the containers. The pod itself does not actually run anything. It just as a sandbox run a containers. What it is, the pod is a box. It's a pod is a box, but it won't do anything. It will the box can be used to run a containers. Understand? No? Keep it high level you okay ring fences. It's a ring fences. Okay, it's a kind of fencing. Pod means it's a fencing. Okay, let's say fences to area of the host OS. Build the network stack. It will be what it will do. It will build the network stack, create the bunch of kernel namespaces, and run one or more containers. It is inside the pod. If you are running multiple containers in a pod, they all share the same environment. Think like as IPC namespace, shared memory, volumes, network stack, everything. If you're running the same pod, it will running everything in the shared there. All those things like a namespace, shared memory, volumes, network, everything. The pod, what are the single same pod having the inside the pod, how many containers are running? Every containers are using this memory and the volumes, network, everything will be shared. As an example, this means that all containers in the same pod will share the same IP address. Okay, if a single pod, if you run the multiple containers, all are used the same IP address. All are using the same IP address. Kubernetes principles for operations. Let's see here. It, for example, at this technically we can speak. If the pod is our main pod is running, supporting pod is running, if you want access using the same IP, but these both are running communicate. If they want to communicate, they communicate using the local host. Okay, internally they can communicate local host, but these two containers having the same IP. They don't have each IP, different IP. Understand, guys? That's what it is. Just in theoretically. Now what we do, the tightly coupled. This is the we are not running in a pod. We don't deploy the like a different kind of application in the single pod. What we'll do, we'll loosely couple. Now we different like a, again we can do this different pods in the different ways, different places. Pods at the atomic unit. Okay, let's see here, because we won't do in the if you want run the 5 pods, we won't run the 5 containers in the single pod. We won't run the single pod. What we'll do, we can run this in the each every pod is a one container here, because even if we go down, then entire entire application will go down, right? So that could be the reason. Even one pod go down, our application will be serving, no problem at all in this case. That's the reason each pod means one container will we were running. Okay, we are not running a, we have option to run up 5 containers in the single pod, same application, but we won't do that, because even that pod gone, then entire all application will go down. Even the different 5 containers, 5 applications also we can run the single pod, but even that also entire application will go down. This is one service, let's say. Understand now, there is a 5 service in our application. Even 5 services also we can run in the single container, single pod also. That's also possible. But if that pod will go down, entire 5 application will go down. Okay, if the same way, if you're running the same application 5 containers, only that one application will go down. Even that also you don't want to go down. Let's make it for that 5 containers in the same application in the 5 pods. Even one pod will go down, another pod will automatically create for us. Okay, and the next, even though it will serving for us. Yes, different containers. No, here the Monica, remember, it's a pod. It's a pod. Each pod has a different IP. Each pod has a different IP. Inside the pod, there is a 5 containers. All containers have the same IP. Understand now? No, it's a, let's say there is a 5 boxes here. Now this here in this image. In this 5 pods having the 5 different IPs. Understand, right? But in this case, in this like left side, we have this, right? Here. It has the single IP. It has a single IP. But here, this is a different IP. 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 Even if we'll go down, that is the 4.3 application is there to serving purpose. In this case, if it will go down, then entire application will go down. Okay, that's the reason we are not running the multiple application in a single pod. That is the reason we ran for the even same application also. Each application is a different pod we are running. The different pod we are running. Okay. Now let's discuss about the pod lifecycle and deployment via replica set and services. We'll talk about this further. This is the main. Okay, what is the main components for Kubernetes is like is only the pod, replica set, service object, and deployment object, service object. These the four is enough to run your application. Remaining all are extra. Network policies, and let's say what you can say, daemon said job, cron job, persistent volume claim. All those are the extra bonus stuff. Okay, but everything will come. Namespaces. Okay, those are the extra steps. We'll talk about the all one by one for the next further classes. And tomorrow, guys, tomorrow can we take session morning? Are you guys okay for tomorrow session for everyone? What we do tomorrow, 31st only, no? Okay, we'll meet tomorrow. And tomorrow we'll set up for Kubernetes cluster as well. Okay, installation of Kubernetes cluster. And you guys can be, start with this. And maximum next 20 days, let's say this month, 2025, almost our course will be complete, guys. Okay. Terraform, if pending for Terraform, maybe we'll take 2 more weekends extra. Okay, 2 more weekends extra. That will continue with the weekends. Okay, again instead of go for the weekdays. We'll see based on the topics are pending. We'll see that 1 or 2 topics we can meet normally. If we're pending for more topics, then we can continue with this weekends. Maximum January end will close this course actually. Okay, fine guys. Then see you on tomorrow. Bye guys.